So hey, I just was looking at some stats for COVID, and there's some concepts that have been bothering me this whole time, and looking at it. And as a math teacher, the only thing I know to do to get something out of my mind is to explain it. And so what I wanted to do is I wanted to look at some of the stats and what a normal curve is, what herd immunity looks like, and things like that. I don't know a lot about epidemiology, like many people who are academics. You've probably been reading a lot, maybe, I don't know. But what I do know is that, or at least seems, that generally an infection curve looks somewhat like a skewed normal curve to some degree. Say, looks something like this. And whenever we reach the peak, which has been weird with COVID, we'll let that go because we messed with the curve by putting in restrictions, by social distancing and everything else. We've been manipulating the curve. And as a result, the COVID infection hasn't taken a normal infection rate by any means because, well, it was kind of terrifying what might happen. But whenever we reach the peak, then what happens is things start to decline. The one thing I don't know well, from everything I'm reading, herd immunity is reached at the point at which it's kind of run its course. I'm not clear if it's the point at which it's run its course or the point at which it hits peak and starts to decline. I think I've been mistakenly referencing it as the point at which it hits decline, or hits the top of the peak and therefore shifts into decline. I'm starting to think I'm wrong on that one. But admittedly, I haven't read enough. I am not a trained epidemiologist. I'm just a guy with a bachelor's in stats. But as such, I'm in fact I just can't look away from any of this. So here's the thing about the stats with COVID. None of our curves are going to look like a normal curve because we don't know that we started testing at the beginning of the infection. In fact, we know we didn't start testing at the beginning of the infection, and we also know for a fact that we didn't have adequate testing to detect all cases at the beginning of the infection. And then you've got the thing where people don't come in or not to actually be screened, things of that nature. So what we've got is a curve where things don't go gently up as things ramp up. In fact, what we saw was a spike, what looked like exponential growth, which again is not quite what things look like. What we were probably doing is detecting the peak. We were getting our testing and everything up. So at the worst case scenario, we got our testing primed and appropriately applied to detect the peak. We don't know that for a fact, but that would be kind of the best scenario. The worst scenario for us ever predicting anything again in the future would be if we got our testing up to speed as the numbers were already coming down. And so as a result, what we did is we met the down curve and then followed the down curve down. You could look at point of inflection and things like that in the data to see if it was a gentle, gradual change in the infection rate. And from what I've seen, it kind of looks like that. New York, we may be wrong because we just peaked and dropped, but both sides of the curve look relatively similar. So I think we got testing up to meet it as it came up. But what that means is the curve looks something like this, where it goes up and then it comes down on the back end. The problem with that is we don't know how many cases were on the front end. We missed them. People were in and out, done with COVID. People may not have gone in or anything else. But what we do know on the back end is that we have detected a lot more people. Now, a common practice in stats is when we don't know the other half of the curve, we assume normalcy, which I'll admit, assuming normalcy in this situation is probably not perfectly kosher, but there's a lot we don't know. And so I'm guessing in the dark here. But if we assume normalcy, maybe we can kind of guesstimate how much we missed. And so taking the case of New York, where it's pretty much run the back end of the curve, all statistical information looks like it's come down and it's kind of run through its course, as it were. So we can take that peak point to the end and we can find that number. And that number is about 224,000 people. And we can say, flip it around the other side and get an estimate of how many total people potentially had COVID in New York, which would be about 448,000. Again, these are rough numbers. I'm not publishing a paper or anything else. I'm making a YouTube video on it. So somebody else will do it because I'm busy with my stuff. We look at that 448,000 number. We can divide it by the population of New York. It's about 20 million. Why are you doing that? Well, we've had a lot of debate and talk out there about whether or not it's asymptomatic cases are 4 times. I've also heard 10 times. I actually personally favor 10 times just because of the way it looks in the numbers. As a mathematician, I don't care what that number is because the 25% herd immunity, again, is us seeing a relationship and functioning off that relationship. As a mathematician, numbers are all made up. It's our relationship with those numbers. So it really, what's real and what we really detect is all kind of relative. As a person who works with numbers, it's what's useful. And so is it 4 times? Is it 10 times? I don't know. It could be descriptive, though, to whether or not this flu bug is drastically different from other ones. We know it's more lethal. We know the symptoms are worse. We know that more people are dying. Again, if symptoms are worse, then those people that would have been on the severe side of the flu are now being pushed over into, needing ICUs, potentially passing away. We know symptomatically this flu bug is far worse. The big question, and a lot of the reason why we shut down, is does it spread faster and easier? Because that's what we heard a lot about, and that's why we're wearing masks and everything, and we're doing social distancing and all this stuff. If the infection has run its course and herd immunity seems to be matching a regular flu bug, and we know it's from a similar strain, what's going on? So we divide our total number of people, that 448,000, by 20 million. And we end up with a 2.23%. Now, this is as of today. The curve hasn't completely rocked out the back end. And again, we're estimating the front end. We don't know that peak was a true peak. It went up and down real quick, which I don't know if that's how epidemiological normal curves work. I don't know the true shape of it. And again, I'm not going to get into it. The crazy thing is, if we look at the 4 times number, 4 times 2.2 would mean that we are reaching herd immunity somewhere around 8% of the population infected. And that's assuming for every person infected, there are 3 people who that were symptomatic. There are 3 people who were that were asymptomatic, which would mean a total of about 8%. If COVID herd immunity is being reached at 8%, then it is far weaker and spreads far less than a flu bug. Now, admittedly, the 25% number is based upon things like vaccination and other things we have. But I'm just going to assume the epidemiologists work out that number for a reason. That when you hit, there's research to back that up. Otherwise, why would really smart people be talking about it? And then those same really smart people saying we don't expect it to be anything other than 60% or far worse. We heard a lot of that stuff back in March, but honestly, they were guessing. They couldn't see any of the curve at that point. Until it turns down in terms of modeling, you can't do anything. So it was great estimates. They were guesstimates. And the entire purpose of science is then to reevaluate our assumptions and see if they're still holding true. If we look at the 10 times number of that 2.2%, I hope you can do the math, it's 22%. That seems really eerily close to the 25%. Now, I've just been running this number for a good long time. This isn't like chicken leading the egg or cart leading the horse. This is a number that I saw about 2 months ago, so I put it into my stats. But when I ran the numbers today on New York, and I did this little inversion flip to try and get the whole curve and try and see what things were looking like, that means that if New York has run its course, it has achieved herd immunity. A, that 10 times number is probably a little more accurate than possibly, we had thought. And B, if we use that number as a useful number to multiply by the total number of infections, we may get an estimation that is now telling us that that 25% herd immunity is actually holding true for COVID-19, which would mean, for all intents and purposes, in terms of infection rate and spread and the back end of the actual curve, this looks like a normal flu bug. Now, I'm putting this video out there. People will probably hate on me. That's cool. Don't mind that at all. The best part about being a scientist and running numbers and looking about this stuff is being wrong. So I totally celebrate that. I expect that I am, because I'm a statistician who works in educational psychology. I'm not an epidemiologist or anything else. But it does give us a measure, because without a vaccine, then every state needs to get to that 25% number to kind of return to normal. This also can serve as a model of looking at state-to-state travel and looking at issues around whether or not people can go to parks and things like that, because once we hit that point, are people still going to get it? Yeah. Can it grow out of control? Well, if 25% of the people have had it, that seriously limits the spread overall. And as a result, it kind of diminishes things, theoretically. We don't know. If New York opens up and explodes again, the reason Korea is showing resurgences is they are nowhere near the 25% number. Most of the places that are seeing bump ups and bumps downs and bump ups and bumps downs is because they lock things down so hard that they actually knock the spread down somewhere before the 1% mark. And if you knock it down somewhere before the 1% mark, you've got a lot of population that's still vulnerable. Maybe the hope for that is to run it out to a vaccine. That means doing this until we have a vaccine. But there are about 10 states, 10 places, including Washington, D.C., that have gotten beyond that 8% mark, which is where things start to kind of dip down, which I was running off of New York, which also appears to be wrong. It appears to be somewhere around 10 to 12% is when it dips back down. And those states that get past that point then are on the downward curve. We are 60 days out from New York crossing that threshold and coming down, and they've been coming down at 5% of infected being diagnosed per day, which shows us the global decline. But it was really crazy to me, that 22% number. As I was running things this morning, I was doing my little tweet thing, and I had to say something about it, because I don't know, maybe there's something here.